Hello, my name is Jake. I'm a mathematician and a math tutor from Chicago. In this video, I'm going to go over the quiz that's on the screen now. So you should watch this if you are an abstract algebra student and you want to test your understanding of cyclic groups. And I'm also going to put a link to the quiz in the description of the video. So if you want to follow along that way, you can do that. All right, Cyclic Groups Quiz. It's all true, false, and it's only 6 questions. Suppose G is a group and H is a subgroup of G. True or false? 1. If G is cyclic, then so is H. And 2. If H is cyclic, then so is G. Suppose G is a group and H is a quotient of G. True or false? 3. If G is cyclic, then so is H. 4. If H is cyclic, then so is G. Suppose G is the direct product of groups H and K. True or false? 5. If G is cyclic, then so are H and K. And 6. If H and K are cyclic, then so is G. So if you know what subgroups, quotients, and products are in group theory, and you know what cyclic groups are, this quiz should be approachable. And if you only know what subgroups are, then you can just focus on 1 and 2. If you only know what quotients are, you can just focus on 3 and 4. And the same thing for products. So I'm going to take just like a second or two break, and then I'm going to come back with the answers. So if you want to keep thinking about it, pause now and come back when you're done thinking. All right, break is over. Time to go over the answers. So I'll just go through them one by one. Suppose G is a group and H is a subgroup. 1. If G is cyclic, then so is H. This is true, and it's one of the big theorems in most intro abstract algebra courses. So the main ingredient to this proof is the division theorem, and I put a link to a discussion about this theorem here in the document. So if you're a little shaky on what makes this true, you can click through to the link and there's a pretty good discussion about it. For 2, if H is cyclic, then so is G. This is very false. There's lots of counterexamples. Take G to be any non-cyclic group and then take H to be the trivial subgroup of G. And the trivial subgroup is always generated by a single element because it only has one element, and so it's a cyclic subgroup. All right, for 3 and 4, suppose G is a group and H is a quotient of G. True or false? If G is cyclic, then so is H. This is true. Any generator in G will be identified with a generator in the quotient H. And if that doesn't make sense to you, there's a link to the proof here. And 4, if H is cyclic, then so is G. Again, this is very false. There's lots of counterexamples. You can take G to be any non-cyclic group and then take H to be the quotient you get by identifying every element of G to one another. All right, for 5 and 6, suppose G is the product of groups H and K. True or false? If G is cyclic, then so are H and K. This is true, but it's true because of part 1 of the quiz. So the factor groups H and K are identified with subgroups of the product H cross K. And subgroups of cyclic groups are always cyclic. So if the bigger group is cyclic, if the product is cyclic, then the 2 individual factors have to be cyclic just because they're subgroups. And last one, if H and K are cyclic, then so is G. In general, this is false. So for a counterexample, you can take the 2-element group Z mod 2Z. That group is cyclic, but if you take the product of that group with itself, you get a 4-element group that's not cyclic. But in some special cases, this is true. So you can take the product of Z mod 2Z with Z mod 3Z. This gives you a 6-element group. And the 2 factors are cyclic, and also the product is cyclic. So I think number 6 is kind of the most complicated answer out of all of these. Except for maybe number 1. That's kind of the most important answer out of all of these. So that does it. That's the quiz. I hope you found it helpful in some way. If you are looking for a math tutor, my contact info is in the description of the video. After the events of 2020, I do all my tutoring online, so feel free to get in touch and I will get back to you with my schedule and my fees and that sort of thing. All right, have a nice day.